Hi, today we are going to discuss about the third quarter topics, which is starting with the electrical charges and the Coulomb's law. So this is the Coulomb's law part, which is our first topic for the third quarter. Now, to proceed with electrical charges, we need to know first what is an electric charge. Okay, so electric charge is an attribute of matter that is fundamental as mass. Mass, it is innate sa ato ang let's say sa ato ang object. We have an object, we have a matter, then it has mass because it exists. Okay? Now, same as that, kinaman siya mass because it is a matter, na siya mass, and at the same time, na po siya electric charge. Okay? So, an object, or a matter in that instance, has its innate charge. Okay, so remember that we are talking about the frame, or the frame of reference here is the charges are at rest. Ito sa electrostatic. Okay, so electrostatics, it means the charges are not yet moving. Okay, so electric charge, it is the basis of the fundamental interaction among the particles. So every particles, they have this interaction, and that is the basis, or ang gibase ana nila nga interaction is because of their own electric charges ana ng mga particles. Okay, so ginatawag po nila ang ilahang electric interaction with electrostatic interaction. Okay, so we have electrostatic. Bear for me for a second as I draw. Wala ko'y pen. Statics. Okay, so electrostatic. Electro means it is from the word like the charge. Okay, then we have static. It means at rest. So your charges at rest sila. Okay, so this interaction, kaning electrostatic interaction, kani siya is mauna sila ang gahold sa imuhang atoms, sa molecules, sa inyong bodies, okay, and other applications. Basically, it is the strongest interaction. Okay, kay kung wala sila, wala ng electrostatic interaction or the interaction between the charges, dili man mabuo ang isa ka matter. Kay wala may mag-hold or wala may interaction between atom to atom or molecules to molecules. So wala ma-form. Okay? So that is why electrostatic interaction should be the strongest interaction. Okay? Okay. So electric charge can have two types. We have the positive charge and the negative charge. Okay? So every matter, they can have these charges. Okay, so you have positive charge and negative charge, but most matter have a neutral charge. What we say neutral. Okay, so ng neutral. Neutral means balance or equal ilang numbers nga positive charge. Let's say we have a positive charge of 3 inside the matter, and napo sila negative charge nga 3. So when they are existing with each other, they balance each other out, or they cancel each other out, and that means ang ilahang charge or ilang total charge will be 0. Okay, kaya mo naman sila makancel, positive plus negative. Okay, so we have 0 because they are equal. Okay, so we also have here their attraction. Say attraction nila. So if we have two like charges together, they will repel each other. Okay, so we have here a positive and a positive charge. Say this is a positive charge and this is a positive charge, as you can see. So pag atuan na silang ipaduol, the charges will repel each other. Okay, so bulag sila. Okay, that is because like charges repel each other. I will explain later on nganong ing-ana sila. Okay, nganong repel man ang duha ka like charges. Okay, so then we have the unlike charges, but different ang ilahang charge, then they will attract each other. So that will be positive and negative. So they will attract each other, then pilit sila. Okay, so Now, neutral matters contains, di ba ningon ko, contains equal amounts of positive and negative charge. Okay? Now, this here, okay, they are governed by the Newton's third law of motion. If you have remembered Newton's third law of motion, ningon ta na in every action there is an equal and opposite interaction. So meaning ana, so gimin ni Newton anang equal. Okay, equal, they say that in every interaction or in every action there is an equal and opposite reaction. So, meaning ana iyang equal. Say, nag-equal. Nag-equal sila og magnitude. Okay? Kasi na magnitude? Magnitude sa force. So, it means here that ang force nag-exert ani ni Q1 kay Q2 will be the same. Let's say that is 5 newtons. So, kani po si Q2, ang iyang exert pod na force dariya kay Q1 will also be 5 newtons. In that way, same or equal sila og magnitude sa force. Force ha, not the charge. Lahi si charge. Okay, lahi si Q1, lahi si Q2, lahi ilahang individual charges. But the force that they exert to one another is the same. Okay, so sa puding opposite. Opposite ang ilahang direction. As you can see here, the Q1 is going to the left. Okay? So, pag interact ni Q2 sa iyaha, si Q2 pod is padulong siya right. So, they are opposite in direction. Equal og magnitude sa force, pero opposite og direction. Okay? So, same thing happened is happening here in the unlike charges attract sa mga dili pareho og charge. So here they have same, let's say 5 newtons gihapon nga force, 5 newtons. So equal gihapon ang ilahang magnitude of the force that they exert to one another. But they have opposite direction. So Q1, the positive one, is going to the left, right, and Q2 is going to the left. So either way, they are, even if they are like charges or unlike charges, the Newton's third law of motion applies to the both of those interactions. Okay, so nagapon si third law. Okay, so next. Okay, so here, para sa asa man day itong kaning like charges and repel or unlike charges attract. Okay, so it is actually seen in some technological applications or technology. Okay, so iyahang importance. So here we have a schematic diagram of a laser printer. Okay, so laser printer usually, let's say, pareho na siya sa photocopier. Yes. Okay, so in a photocopier, we have a toner. Mo na siya ang marag nagkapyot dira ang ink. Okay, and we have a rotating imaging drum. So laser printer, how do they work? First is we have a rotating drum. Okay, so natay drum, and it is actually neutral at first. Neutral pa siya. Dayon, na ay wire na nag-spray og ions sa imong drum. Okay? Ginahatagan niya siya, kani siya ang nagahatag og positive charge sa imuhang drum. So, kung off pa imuhang drum, it is neutral. Pero pag on ana niya, na ay wire ana na mo spray og positive na ions, making your rotating imaging drum positive. So, positive siya. Okay? Now, naatay laser. And laser is a negative charge. Okay? So, negative charge ang iyang ginahatag. So, kaning laser, siya ang kibali musulat or mo-draw sa dapat i-print ni printer. Okay? So, let's say that we have an image. Okay? Image. So, let's say that kani siya si rotating drum. Ano na to? Kung kani siya si rotating drum, Asa ba? Wala mo ko ano. Okay. So, if kani siya si rotating drum, ano, okay. If this is rotating drum, okay, ato na siya ana, ayan siya. Okay? So, kani surface niya diri let's say kani siya, mo ni siya, diri yung surface. Okay? So, magtuyok man na si rotating drum, magtuyok siya, tuyok, tuyok, tuyok. Okay? So, positive to siya. Gihatagan siya og wire. Gihatagan siya og positive ion sa wire. Tapos, si laser is siya ang musulat kung unsa tong imuhang image na ganahan i-print. Okay? So, let's say that you want to print, let's say, A. So, remember that they are all positive. Positive pa si drum. Okay? Bear with me for a second. Let's say, positive sila tanan. Then, si laser, maghatag siya og negative charge to form the image or to form the letter that you want to form or imuhang i-print. So, let's say, gana siyang circle. So, let's say, circle, negative na siya ha. So, it will form a circle. As you can see here, working na siya. It will kind of form a circle. Form siya circle. Okay? So, with that, kay na-form na image. Okay? So, butangan pa natog positive sa sulod. Para katong image siya ginang makita. Okay? So, kanang black, mo na siya si negative. So, now, si toner, as you can see here, si toner, it is said it is a positively charged. So, using the interaction between like charges and unlike charges, pag pareho silang positive, mo repel siya. Pero, pag negative ang isa, tapos isa kay positive, mupilit sila. So, here, with the toner, mo-repel siya, diri tanaw nato diri mo-repel siya sa mga spaces or sa mga areas nga naay positive. Mo-repel siya. Asa siya mopilit? Sa katong imuhang image. And the toner is your ink. It means the ink is positively charged. So that is why ang mupilit sa drum is positive, forming your letter. Okay, or forming your image. Napa na sa drum. Okay, napa sa drum. Okay, so, nipilit na. As you can see here, nipilit na siya ang ink sa atong rotating drum and dira na nato i-feed si paper. So, si paper, actually, they are actually neutral, no? Neutral siya at first. But, inside the laser printer, naapoy wire na mo spray sa iyaha og negative charge. Remember that the toner is positive. Na-attract siya sa drum kay naay negative dito nga na-form dito sa drum. Okay, na nag-form sa image. Now, since the paper is negative and your ink is positive, katong ink na from the drum, mubalhin siya kay paper. Now, as you can see here, nibalhin siya kay paper, kay na-attract na po siya kay paper, kay negative man siya. Okay, now, ink, ma-absorb na siya sa paper. Mo na siyang mupilit siya dito sa ato ang papel. And, when that happens, natay fusor rollers na mag-permanently attach siya ang mag-permanent attach sa imuhang ink padulong sa imong paper, no? Siya ang kanang tig-flatten ba, sig-flatten sa imuhang papel o sa imong ink. Okay, so that is how the interaction between the charges work in technology. So isa ra ni siya sa mga applications sa atong like charges and unlike charges na interaction. Okay, so then we have the three ways of charging. So, kato natay i-charge dito. Like here, the wire sprayed positive charge onto the drum. Okay, so that is a kind of charging. Gihatagan ni mag-charge ang isa ka neutral nga object. Same here with the paper. Gisprayhan siya og negative charge. So, naa siya, gi-charge na po siya or gihatagan siya og charges from is neutral na kanang charge. Okay, so with that, it is what we call charging. Charging has three ways. Na siya tulo ka way. Natay friction, by contact, or by induction or induce. I-induce siya. Okay, so first, we have the charge by friction. Okay, so charge by friction is when a material rubs. Okay, so gi-rub nimo ang duha ka material, rubs one another. So gi-rub nimo sila, then ang isa ka material is mag-lose siya og electron mobalhin sa another thing. Okay, so just here we have a cloth and a rod. So pag imo na siyang i-rub sila duha, okay, the rod loses an electron. So kung, 'di ba, this we have here uncharged cloth. When we say uncharged, it means they are neutral. Equal ilahang positive and negative. So they have equal positive and negative. Positive and negative. But when we charge them by friction, mawala ang negative or makuhaan og negative charge si rod. Okay? So ang negative niya nga charge mobalhin or ma-transfer kay cloth. So it means kinawalaan man siya og electron or negative charge, mas daghan ang iyahang positive charges kaysa sa iyang negative charge. It makes the rod positively charged kay nakuhaan man siya electron from the neutral state. Kay equal sila, then nakuhaan siya electron, so mas daghan si positive charge kaysa kay negative charge sa iyahang sulod. So it becomes positively charged. Now, so it doesn't mean na nawalaan siya tanan sa iyang electron. Positively charged or positively charged material can be mas daghan rang iyang positive charges kaysa sa iyang negative charges. Yan na. It doesn't mean na dapat mag-zero gid ang iyang electron. No. Now, since si cloth is nag-gain man siya og negative charge, so mas daghan na iyang negative charge kaysa sa iyang positive charge. Okay? So, it doesn't mean na nawala iyang positive charge ni cloth. No. Mara siya mas nidaghan ang iyahang iyahang negative charge kaysa sa iyang positive charge. So, that means the cloth becomes now a negatively charged cloth. So, after rubbing them both, pag humani mag-rub ana nila, the cloth becomes negative and the rod becomes positive. So, pag imuha na siya iduol sa each other, they will now attract each other. Okay, they are opposite naman ang ilahang charge. Okay. Next is charging a neutral object by conduction. Conduction means by contact. No? So, we have here by contact. So, conduction, so from that itself, okay, ako saying move. Okay. So, pag imuhang where nakay metal sphere or nakay object na daghan siya og negative charge, pag imuha siyang i-contact sa isa ka neutral object, mo-flow ang iyang electron sa katong negative na charge padulong sa imuhang neutral object. So just like what happened here, so we have a metal sphere nga puno og negative na charge or daghan siya excess na negative charge. Then na siya neutral na electroscope or let's say neutral nga material. So pag i-contact nimo na sila duha, ang excess na electron or negative charge sa imuhang object or sa imuhang sphere will now flow to the neutral object, which is your electroscope. Okay, so with that, na-conduct or na siya conduction or na-charge na nimo ang isa ka neutral object. Okay, so passing of electrons. So that is neutral object by conduction or by contact. Okay, next we have here the charging by induction. Okay. So charging by induction, it means induce nimo siya. Induction or charging by induction is unlike friction and conduction that requires contact. Or dapat mo pilit gid sila. But here in induction, dili na nimo need na mo contact gid ang imuhang source o ang imuhang i-charge. Okay? So for example, we have here two metal spheres. Okay, si A ug si B. Now, A and B are neutral. As you can see here, blanco sila. So it means neutral. Ilang positive charge and negative charge is equal with each other. Okay. Now, if hatagan nimo sila og source, okay, so naa kay presence sa imuhang positive charge, wala nimo siya gi-contact, as you can see here, wala niya gipilit ang iyang source kay A, but giduol ra niya. Now, positive attracts negative, and negative, as we have learned sa ato ang sa chemistry, sa ato ang mga discussions before, that negative is or electron or negative charge is the most free na charge. So, mo-flow ra na siya from one object to another. Dali ra siya mo-flow. Okay? So, here, we have a positive charge, and ang electron ni A and ni B kay ma-attract sa iyaha. So, it means, si A, okay, so si A, neutral man to siya at first, but si B, ang iyahang mga negative charge is mo-flow padulong kay A. Nga naman mo-flow siya dito, ma'am. That is because of the attraction here. Na-attract sila sa kay positive. So, kay na-attract man sila, mo-flow sila to that side. So, bale, ang tanan na negative charge, nagtapok kay A. Okay? Or let's say, some of the negative charge, or most of the negative charge, nagtapok kay A. So, that means, makulangan og electron, or makulangan og negative charge si B. Kay nag-flow naman iyahang negative charges dito kay A. So, it is left with positive charge. Si A pod is nadungagan iyahang mga electron. So, A becomes negatively charged and B becomes positively charged kay nakuhaan siya electron. Okay. So, once that happens, pag is-separate na nimo na sila duha, A becomes negative, B becomes positive, so they will now have their induced charge. And pag iduol nimo na sila, mag-attract na sila because they are opposite. Okay? So that is charging by induction. Okay? So we have what we call the conductors. Conductors, or electrical conductors in this instance, because we also have heat conductors, and some of the materials or some of electric conductors are not very naiuban na dili good in heat. Pagconduct of heat, okay? So that is very rare. But yes, we're talking about here the electrical conduction or conductors. Mo ni sila ang magpa-flow sa imuhang mga negative charge or sa imong charge. Okay? So electrical conductors are materials or substances which have free electrons. So free electrons can move freely throughout these materials. Okay, so a small region of good conductors when charged can distribute itself over an entire surface area. Okay, so saan siyang free electrons? So most of the conductors, okay, have free electrons. Let's say that we have a nucleus. The nucleus, inside that, we have positive charges. Okay? So, kung pila ang imuhang positive charge sa sulod, maupod ang imuhang electric charge sa gawas. Negative charge sa gawas. So, if we have 9 positive charge inside the nucleus, then you also have 9 negative charge outside the nucleus, which is on the orbit or the orbitals, or ginatawag natong energy levels. Okay, so kanang naa siya sa energy levels. Now, kani siyang free electrons, mo ni sila ang mga naa sa valence shell. What do you mean by valence shell? So most of the conductors or elements that comprises or that is a good conductors, naa sila'y excess na electron. So in here, for instance, copper has one electron that is free or nasa sa pinaka outermost um, energy level. Okay, so if you have remembered in your chemistry, we have what we call the octet rule. No, so octet rule means basically your element wanted to achieve stability, and that stability means dapat makabuo sila og 8 nga charge sa ilang energy levels or at least 8, yes. Okay, so pag mo exceed sila ana, then mo na nang ilang ibutang sa next na energy level. So in here, let's say naatay duha ka energy level, so isa ka energy level, for instance lang sa isa ka energy level, puno na siya. That is why, kay copper, na siya isa, I think copper has one excess electron or negative charge. So, isa ra ang iyahang sobra. Katong diriya sa iyahang energy level, that is already full. Okay? So, what do you mean by full? Because of the octet rule, dili na niya ihatag. Kaya stable na good siya. Okay? So, that is what they want to achieve. No? Para mas stable ang ilang element, they want to achieve the octet rule. Now, what will happen to this excess na negative charge? So, that is where pairing comes in. So, ng pairing, ma'am. Let's say, muna siya ang ihatag nila is either mo share sila sa ilahang excess na electron with another atom or ihatag nila completely. Okay? So, in this instance, si copper is ihatag na lang niya completely. Ganun ihatag man nila. That is because isa na lang man ang iyang excess. Isa ba? Yes. Isa na lang man ang iyang excess. So, kay isa na lang man ang iyang excess, dili na niya need i-share. Pwede man niya i-share actually. Pero, mas dako manggod ang energy na iyahang magamit if mangita pa siyag 7 kabuok para makompleto ang 8, kay isa na lang man ang iyahang isa na lang man ka electron ng isa lang man ang electron niya nga excess, so need niya og 7 more nga negative charges. Pero dako ang energy ana. So what copper will do is instead of getting 7, ihatag na lang niya ang iyang isa, thus making the copper stable. Okay, so that is how conductors work. For this instance, that is copper. Okay, so that is what we call ionic bond. Okay, so ionic bond is basically giving. Okay, so nag-give siya o iyahang excess na electron or excess na charge. Okay, giving it completely, while covalent is like sharing. But covalent usually exists with non-metals. But since these are all, the conductors are mostly metals, so they are an ionic bond. So ginahatag nila completely ang ilahang ginahatag nila completely ang ilahang excess na electrons. I think copper has 3. Let me check. 2. 2 valence. Okay. So either 1 or 2. Okay, so yeah, pwede siya 1, pwede siya 2. Okay. Tama lagi 1. Nasa 4th shell. Okay, so same, na siya 1. Okay, 1 excess electrons. Okay, so kani siyang free electrons kay, yeah, as I have said before, because of the ionic bonding or kani tungod sa ang copper or atong metal is ihatag na lang man nila ang 1, okay, ang 1 na or excess nila nga electrons. So, for instance, this is a copper wire. Okay, so this is a copper wire. And inside the copper wire are lots of copper atoms. Okay, so let's say that this circles here represents the atom. Not accurate, but you get it. Okay, so that you can get it. Okay, I'm gonna make it bigger para dali siya ma-understand. Okay, so let's say that those are atoms inside your copper wire. Okay, so your copper all has 1 electron na excess. So each atom there has 1 electron remaining in their valence shell. So, syempre, pareho man sila copper tanan, ganahan sila na ihatag ang ilahang electron sa sunod nila nga atom. Pero ang sunod nila na atom, kinihatag naman pod, kay because they're also copper, so they want to give it to them, to their sa sunod nila. So, that is why, if naatay electricity, electricity is charges that is full of negative charge or electron. That is why it is called electricity. It is from electron. Okay, so electricity introduces electron in your wire. Nganong best conductor man ang metals, and that is because pag hatagan silang electricity or negative charge, hatagan silang negative charge, na remember that they have an electron na daan. So pag hatagan pag hindi mo sila negative charge, so may ilang buhaton. Ilang buhaton is ipasa nila sa next nila nga atom or sa next na atom sa ilaha. So, for instance, kung kani gihatagan nimo siya og electron, kani siya iyang ibalhin sa isa sa sunod niya. Pero katong isa niya katong sunod niya na copper nga atom, ihatag na po niya sa sunod. And the process goes on because they are all copper. Okay, so that is why they're very good conductors, and that is because they don't want the electrons. Okay, so they have free electrons that they are willing to give up. Okay, so mo to conduct sila og electricity faster because of that. No, kung pasa-pasa nila hantod sa niabot na lang siya sa kung asa siya padulong ang electron. Okay, thus making the electricity move. Okay, I hope you get that. Okay, so yes, so the best conductor is silver. Silver. It has the smallest resistivity, or the material itself has the smallest resistivity, but nganong copper man ang ato ang ginagamit for wirings. That is because silver is not cost efficient. No, silver is a precious, let's say na dako iyang cost. Imagine na po ninyo, no, so na ang ato ang wirings are made of silver. Copper manggali makawat siya. What more if silver ang atong gamit, okay, or gold. But the silver is the best conductor, but copper is the most cost efficient. No, cheap siya, cheap relatively, relative kay silver. So mo nang ginagamit nato si copper. Okay, so second option nila na si copper. Okay, now let's go to insulators. Insulators, these are electrical insulators. I always emphasize this electrical insulators because most of these insulators, especially rubber, are not good with heat. Mao nang masunog ang mga rubber pag naay heat or too much heat. Okay? They're so electrical insulators are materials or substances in which all of its electrons are bound to atoms and doesn't have free electrons. So basically, insulators have already followed their octet rule. Stable na sila, mo nang di na sila manghatag. Okay? Okay na sila bale. Mo nang di na sila manghatag. Of course, ikaw na kompleto, dili pagpaya ka manghatag. Okay? So, yan na siya. So, ilahang mga chemical compounds or chemicals or elements that comprises them are already stable. Okay, so they don't have free electrons. Then that is why paghatagan sila og electric charge or electricity, dili mo flow or dili mo budge ang ilahang atoms or ilahang charges. That is because they are totally bound or attracted equal yun ang ilaha or not equal but more about kusog ang ilang attraction between the positive and negative charge inside those materials. Okay, so the movement of free electrons in insulators are opposite to conductors. So a small region of good insulator when charged cannot move to other regions. Okay, so the examples of good insulators are of course rubber because that is what we insulate our wirings. No? So gawas anatong mga copper wires are rubbers because they are very good electrical insulators but not very good heat insulators. Okay, so mo nang pag na ay mo accumulate na charge or electricity in your wirings, let's say na short circuit siya, na-accumulate ang electricity ana or daghan ang electricity na nagdagan dira. So when that happens, electrical energy becomes heat energy. Okay? Kaya wala may nag-resist sa iya dito. Sige na siyang flow sa imuhang wirings. Walay nag-resist. So when that happens, ang imuhang electrical insulator, which is the rubber, dili niya makaya ang heat na gina-produce sa imuhang wire because the electrical energy, pag dili siya ma-spend o maayo, mahimo siyang heat energy. It transforms to another kind of energy. Okay, so another kind of energy just like heat. So that is why pag na-accumulate na heat, melt si rubber. And that is the reason why pag ma-short circuit ang isa ka circuit or isa ka wiring, masunog siya. Okay. So, yes, we also have glass, oil, diamond, and wood. Okay, so that is great. Those are great insulators. Next is we have the semiconductors. Semiconductors are actually, they have properties na pwede siya conductor, pwede po siya insulator. Okay, wait, let me check. Okay, so semiconductors are usually used in sa mga technology, okay, or sa mga devices, equipments, electronic equipments, okay. Ngano na may semiconductors? These are actually materials that are pwede siya mahimong insulator, pwede po siya mahimong conductor. Depende sa iyang pagkagamit or depende sa iyang function inside the circuit. So semiconductor devices, they are the one that controls the flow of the electric circuit. So siya ang control or mo manage sa imuhang electric current. Okay? So examples of semiconductors are silicon. Okay, silicon, tellurium. That is why most of kung tanaw niyo sa mga baligya sa Silicon Valley, they are actually, electronics. Okay, because most of the gadgets and devices use a silicon for their chips. Okay, so that is why um, tinatawag siyang Silicon Valley. Okay, so we have the electric field. Okay, so I just realized. Sorry if matabunan na ako or matabunan sa akong naong ang um PPT. Anyway, I have already gave you I already given you the copy of my PPTs para at least ano na to recall ra ni siya or to review. Okay? So, ako lang dahil na siya i-change, no? Wait lang. Okay, here. Okay. Okay. There. Okay, so electric field. Electric field is a region or space where a charged particle experiences an electrical force. Okay, so remember niyo na that electric field is where your charge experiences an electrical force without contact. Okay, so the charged particle will accelerate to the direction where there is an unbalanced force if there is free to move. So, pareho ako ang gi-explain ganina, no, na like charges repel and unlike charges um, attract with each other. So, nga na dito, ma'am, na kanang mo repel man ang pareho nga positive or pareho nga negative. And that is because of the direction of their electric fields. Okay, as you can see here, positive charges have electric fields flowing outward. Outwards, yeah. So positive plus positive, they are both outwards. Of course, they will repel each other. While the negatives have this inward direction. Okay, pa-inward siya. So that is why if ipaduol nimo ang positive charge na outward and negative charge na inward, mo attract gid sila with each other. That is because outward padulo na dayon siya kay negative na inward. So mag-attract gid sila with each other. Okay? So just like this, here we have the attraction and the repulsion. Nag-repel ang pareho nga negative charge and that is because they're both going inwards. And nag-attract ang positive and negative, that is because they have kanang mo-complement ang ilang electric field with each other. Okay? So the density of lines of your electric field will determine the strength of your electric field. So as you can see here, mas daghan ang lines or arrows ni C, therefore making C strongest among the three. So mas stronger siya kaysa kay B o kay A. Okay, si A must be the weakest one kaya siya ang pinakagamay o density sa iyahang pattern or sa iyahang lines. Okay, kaysa kay B or og C. Okay, then we have the Coulomb's law. Coulomb's law is actually the magnitude or the force, electrical force between 2-point charges. Okay, so remember, dingo siya diri at 2-point ra. 2-point. So it means you are actually observing only 2 charges. Okay? Now what if, ma'am, tolo ang charge nga present? Na isa pa diri Kasi is negative. Then, this is what we call pairing. Depende sa situation kung sa'y pangitaon na Coulomb's law or of electrical force, pwede kanisa sila, then kani, or kani. So, basically, 2 at a time ra gid siya gamiton ang Coulomb's law. Okay? So, it is the magnitude between the between 2-point charges where the electric force is directly proportional sa product sa ilang charge, your electric force, the product of your charge, and inversely proportional to the distance between them, or the square of the distance between them. What's yung meaning, ana, ma'am? So, let's say, if mo double ang imuhang distance, mo double imong distance, or mo double ang kalayon nila, then your force becomes 1/4. Ana, square man. Okay, so 1/4, then 1/16. Okay, so, but it's inversely. So, the more na mulayo sila, magka-diminish or magka-weaken ang electric force between them. And their charges and the electric force is directly proportional with each other. So, pag modako ang ilahang charges nila duha, then ang force mo nila duha will also increase. Increase. Okay? So, that is the Coulomb's law. It follows the inverse square law. Inverse square law in math. Okay? So, remember that the Coulomb's law, kani siyang Q diri is actually like that. Okay? So, it means, dili magmatter, dili sa Coulomb's law, dili magmatter ilang positive and negative charge sa. Okay? Dili sa. Because the Fe here, or the Coulomb's law, just looks, or just, ang iyahang ginapakita raw, ang iyahang ginahatag lang sa ato is ang magnitude sa imuhang force. No, wala pa tong direction. Okay? So, remember na, magnitude pa lang. Wala pa yung direction. Because the direction will actually depend on the charges involved. Okay? So, kung attraction ba siya? Is it attraction? Is it repulsion? So, it will depend on that. Okay? Depende dayon kung asa ang direction anas. Nag-repel sila. Kinsa may positive na padulong sa positive side, kinsa may padulong sa negative side. So, it actually depends on the position of the charges and their attraction with each other. Okay? So, yes, F is your Coulomb's this is your Coulomb's law, where F is your electric force, Q1 and Q2 is your charge, K is actually your Coulomb's constant. Coulomb's constant constant is 9.88 times 10 raised to 9. Positive 9, of course. Then the unit is Newton meter squared over C. Kapala na mamana kay masterman mo. Okay, so yes, that is your Coulomb's constant. Now, Coulomb's constant is also written as this 1 over 4 pi epsilon naught. Okay, so this 1 over 4 pi epsilon naught is just its other, other alter ego. Okay, other personality. Other personality niya, where epsilon naught is actually the permittivity. Okay, so it is the measure of how dense of the electric field is permitted to form in response to the electric charge, and relates it to the unit of electric charge. No, so, oh, sorry. So, bali, kani si epsilon naught is just a constant. Constant na siya. Okay? It is a constant that murag gina-permit, pila ka electric field ang iyang gina-permit sa iyahang sa iyang region or something like that. Okay? So, nga nung i-introduce man ako na siya sa 1 over 4 pi epsilon naught, and that is because it will actually be handy in the future topic, which is on the electric flux. Okay? So, that is the other form, or yeah, the other form of K. Now, if you have already talked about gravitational law, you will remember, or you will realize that the electric force is the same as the gravitational force, or not the same, but they have similarities. Okay, where the force is equal to a constant, then we have the quantity of those observed, katong i-observe nimo na duha ka buok na material or matter over the distance squared. Same sila. Okay? So, yeah, this is a running gag in the community that talks about Coulomb just copying Newton's gravitational law, which is actually, kung tanawon po nimo, if you are going to maghatag kag new idea or new law or a new um, proposition to the community, of course, you need to follow some kind of respect. Kanang dapat i-respect nimo si Newton. Because Newton, if nagganahan ka mag-tackle about force, of course, Newton's law talks about force. Okay, so dapat ang imuhang na-discover or imuhang himuon will respect to that Newton's force or Newton's law of motion, or let's say his gravitational law. Okay, so kani diri si Coulomb is si Coulomb nganong pareho raman ang iyahang equation kay Newton na gravitational law. That is because electric force is also a force. Therefore, the gravitational force nga equation is true and cannot be refuted yet. It cannot be refuted, so it means it is actually true. So dili siya makabuot-buot og concept. Dapat mo parallel siya sa kay Newton's gravitational law or mo respect siya. So since they are both forces, therefore ang underlying concept dira is also the same. Okay, if you have, kung nag-guess ninyo, mo nang giparallel niya ang iyahang equation kay Newton. That is because Newton is already true and accepted in the community. Okay, so now there are also similarities and differences between the electric force and gravitational force. First, similarities, they both obey the inverse square law. You can see that force is equal to the constant, then ang quantity nagikan sa material or sa matter. For gravitational force, we have the masses, and for electric force, we have the charges over the r squared, or the square of the distance between them. So they both obey inverse square law. Okay. Now the charge plays the same role sa Coulomb's law ang charge sa Coulomb's law plays the same role sa m or sa mass sa ato ang gravitational law. Same sila o marag tawag ato na role. Okay, so now the difference between them is the electric force will depend on the electric charge because they're the one involved in our equation, but the gravitational force depends on the mass. Now, the distinct difference ilaha is the electric force pwede siya mo repel as what we have learned kanina, but like charges repel and unlike charges attract. So, the electric force can be repulsive or attractive. Kaya pwede man naman siya negative charge, naman siya positive na charge. But sa gravitational force, it is always attractive because wala man tayo negative na mass. Only positive mass because if you exist, therefore you have mass. No? So wala negative na mass. It contradicts that, the presence of matter. So that is why it is always attractive in that sense. Okay. Now, the electric force is a bigger constant than the gravitational force. Okay. But the electric force is stronger than the gravitational force. If you see here, nga nung electrical force, stronger man siya. Remember that they follow inverse square law. Means, the more na mogamay ang imuhang distance with each other, the more na modako ang imuhang force. Okay? So, the more siya modako. And the electric force, ang involved ani are charges. Gravitational forces involve bodies. Like, body of a person and between the earth, earth to moon, earth to sun. Okay? So, dako ang ilahang distance with each other. It might be meters, it might be kilometers, it might be light years away. Okay? But electric force talks about charges. And charges, they have really tiny distances from each other. So, the more mogamay si distance, the more na modako si force. That is why electric force is much more stronger than the gravitational force. Which is dapat naman po. No, because there will be no gravitational force if in the first place the matter will not be dili siya compact or dili siya mabuo. Because electrical force is the one or the reason why we have atoms, why we have molecules, nganong naay matter, nganong pagtamak nato dili man ta mabungkag, kada step nato sa ground di ta mabungkag, and that is because the electric force or the electric interaction is actually strong. Okay, so that is the difference between the two. Okay, so for example, we are here to solve the gravitational force. Okay, so it's a gravitational force attack. Okay, so calculate the force of gravity that exists between a 60 kilogram person and an 80 kilogram person who are 50 centimeters apart from each other. So that will be itong handy-dandy notebook. Okay, so that will be Fg is equal to G M1 M2 over R squared. Now your G is 6.67 times 10 raised to negative 11. Okay, so ito yung butang niya. Ilan sa kamong unit ha? Okay, let's say that this is your G. Okay, then your M is 60. You can see here, the 60 and 80. So this is a person-to-person na gravitational force, or the force of gravity between two people. Okay. So we have mass. We have person-to-person. So we have a mass of 60 kilogram, so kg, multiplied by the 80 over the r squared. Over the r squared, they are 50 centimeters apart. So remember that is in centimeters, and there's 50 centimeters apart, and r is always in meters. So you need to convert it. 50 centimeters is equal to 0.5 meters. So that will be 0.5 squared. Okay, so here, therefore I conclude that the force between them is actually 1.28. So we can say that the Fg, imuha na siyang i-calculate tanan. So we have 6.67 times 10 raised to negative 11 multiplied by 60 and by 80 divided by 0.5 squared. Then your answer will be 1.28. Okay. So that will be 1.28. 1.28 times 10 raised to negative 6. Like that. I hope that is clear. Igura mo na siya ibutang sa imuhang calculator. Okay? Ano na? Okay, so that is for gravitational force. So let's have another one for gravitational force. We have here to calculate the force of gravity of a 25 kilogram block resting on the Earth, which has a mass, the Earth has a mass of 5.97 times 10 raised to 24 kilogram. The radius of the Earth is 6.38 times 10 raised to 6 meters. So here, unsa ang mga involved na bodies, which is this gravitational force, or we're talking about bodies interaction or body to body. So ang body diri duha ka body diri is ang 25 kilogram na block and si Earth. Because your Earth is also a body that can exert gravitational force. Okay? So, mass sa Earth, mass sa imong block. How about the R? Nganong si R man nato is kaning radius sa Earth. Ngano man. Remember that gravity, ano siya? If this is the Earth, the box or the block, I mean, sits on the crust. Kita na ata sa crust, of course. So it means, and we are very minuscule. Gamay ra kayo ta. Let's say, nga na siya kagamay ang block. Na siya sa crust. Not realistic, but anyway, nga na siya. Now, gravity comes from the core or from the center of the Earth padulong sa iyahang crust. Okay, that is the distance because the block, diba, r squared here, r, or asan na to? R, kanang R na ginamin sa ato ang Coulomb's law and sa gravitational force is the distance between the centers of the matter. No, so center sa charge, padulong sa isa ka center sa charge. Then ang isa dayon is from the center of another body sa gravitational force, center sa isa ka body padulong sa center sa isa pod ka body. So between their centers. So here, the center of the Earth is there, and the center of the box or the block is in there. Pero tungod siyang kagamay, let's say that iyahang center is just like that. So that is your R. And coincidentally, the R that we need in our equation is also the radius of the Earth. No? Radius man is Earth. Mo na yung diameter. Huh? So kung pila ang iyang radius from the core to our crust, maupod siya atong R na atong gamiton para sa pagkuha sa force of gravity. Okay, I hope that's clear. Okay, now with that, we can actually solve for this one. So, bale, 25. Okay. Ako na lang copy-paste. Okay. So, for example, pag mag-solve ta sa ato ang gravitational force, that will be Fg is equal to G. You know, the G is 6.67 times 10 raised to negative 11. Then, we have the 25. Then, sa to atong Earth. Ako na lang ni copy kay kapoy type. Ay, kapoy, i-draw. Okay. Like that. Okay. Oy. That. So those are our masses. Those are our masses. Over their R squared, which is, copy-paste gyapon ako. Kita po lang man ta. Okay. I don't have a pen with me. So, a stylus there. So, nga na. where the G is 6.67 times 10 raised to negative 11. Oh, wait. Kulang. Sorry. Do not forget the square. Okay, because this is inverse square law. So, when that happens, your FG, imo na siyang i-calculate. Your FG is, oh, sorry, 244.6, around 244.6. Yep. Okay, so that is 244.6. Ta-da! Okay. 44.6. So, kung giyon sa nato ning gravitational force, actually, ing ana ra pod si Coulomb's law. Okay? So, Coulomb's law, for example, here, the 2-point charges of Q1 is 25 nanocoulomb and nano. Q2 is negative 75 nanocoulomb. So they are separated by a distance of 3 centimeters. So naka-centimeters na siya, so i-convert pa nato siya into meters. So that is 0.03. So find the magnitude and the direction of the electric force that exerts on Q1 and on Q2, Q1 on Q2, and the electric force that exerts Q2 on Q1. So kani siya iyang gipangita is with the direction. Remember that in here, in our Coulomb's law, ang ato arang mahatag is ang iyahang magnitude or ang value, ang number. Okay? Okay. Daghan gyapon na confused ana. Ang number, kani, ang number, mao na siya si magnitude. Kana. That is magnitude. Okay? Ang electrical force, or I mean, ang Coulomb's law, ginahatag na niya ang number or value, magnitude. Pero wala pa niya ginahatag ang direction sa imuhang force. Diba? Force can be equal in magnitude. So, equal ang imuhang force, but opposite in direction depende sa imuhang charge and depende sa ilahang positions. Okay? So, here, 2-point charges. So we have 20 nanocoulomb, 25 nanocoulomb positive, and negative 75 nanocoulomb. Pag atuwa na siyang i-calculate. So that will be F equal to K, where your K is 8.988 times 10 raised to positive 9. Copy, paste. Okay, so that is your K. Correct. Next is, what is your charge? Your charge is positive 25. Nanocoulomb. So that is times 10 raised to negative 9. That is negative. And we have 75. You might be wondering, nga nung di man nato i-apply lang negative, ma'am? Because they should be in absolute value. It means positive sila. Okay? Wala sa appeal ang ilahang charge. 75 times 10 raised to negative. Dili sa magmatter ilang charge ani. Then what is the distance between them? So that is 3 centimeters. So 3 centimeters, that is 0.03 meters. Then square. So pag imo na siyang isolve, your answer will be, so many, 0.0187. Yeah. So your answer will be 0.0187. Now, this 0.0187 is just the magnitude. Wala pa ta kabalo unsay answer sa A and sa B because it talks about the magnitude and the direction. Now you're here we have 0.187. So if we have a charge that is positive, let's say positive man si Q1, and we have negative na Q2, this is your Q1, and this is your Q2. So they have a, let's say, they have attraction because they are like charges. So si positive will go here, and si negative will go here because of the attraction. So your positive, as you can see here, the force, this is A. Okay? This is A ba? Tama ba? A. Ah. Okay, so si A, unsa ang force nag-exert ni Q1 kay Q2. So that will be positive 0.187. Nanong positive man, ma'am? Look at here. In Q1, its force is going to the right. Therefore, it is positive 0.0187. Now for Q2, it is going to the left. And in the x-axis, basta nakalimot mo, in x-axis, if you're going to the right, it is positive. If you're going to the left, it is negative. So that is why positive si Q1 and negative si Q2. Then your Q2 is negative 0.187. Thus, respecting the third law of motion, na equal sila og magnitude sa ilang force, pero different ang ilahang or opposite ang ilahang direction. Ang isa going to the right, ang isa going to the left. That's it. Okay? So, actually, there are lots of examples in my my PPT. There's, I think, napay duha. Okay, and the answers are there. So you can, nanay answer ani daan, na nasa ubos. So you can try, recall, here. So I will cut the video kay marag mas taas na siya. Lisod na ni siya i-upload. Okay, so yes. If you have questions, you may ask me directly to my Facebook account para dali po na ko siya ma-address. Okay, so that will be all for today for the Coulomb's law. So I hope you have learned something for our electric charges and the Coulomb's law. We will now proceed. My next video will be about the electric flux. Okay, so stay tuned. Bye.